In this video, Glenn Azar will tell us more about the use case at ArcelorMittal.
I think this company needs lots of introduction. It's ArcelorMittal Belgium. They are a very big steel producer in the world, and yeah, this site in Belgium is, or in Zelzate, is a very innovative site that is used to create a lot of automations for sites all over the world. The projects we have worked on is situated in the buffer zone in the plant. So you have a buffer zone. They call it the slab yard. It's a big zone that is full of these steel slabs that are laying there, and three big machines, very big machines, are driving around there and doing some logistics into the buffer zone. So they are bringing these steel slabs from one point to another point, and are also handling these slab piles. So they are taking certain slabs off piles and move them to other piles. What do they wanted to do there? So they have to have a next generation of these slab carriers, and they wanted to have some object detection, collision avoidance, these stuff. So these new machines, they didn't want them to be damaged from collisions with other machines or with these slab piles. Therefore, we have made a sensor study. So you see it in the scheme below. So we have a lot of lidars on this machine, Sorry, IMUs, GPS, encoders, all kind of things. Yeah, vehicle data is also important, of course. Okay, but now we have all this data. We also need to do something with it, because this is a very big stream of data, and the most interesting one here for the perception is the LiDAR. Of course, the LiDAR data, we have 5 LiDARs on this machine. We need to stitch those images together, and you see it there in the movie, the upper movie. We have made an algorithm that here automatically stitches these LiDARs together. So we are searching for same parts in the images. So we of course have an initial setup that we are trying, but then we search for small deviations. For example, supports that are a little bit different. Yeah, sometimes hot and cold over such a big machine, it can differ in the image of a few centimeters in the LiDAR point cloud. So we need to put everything together and stitch everything together. So therefore, we also need IMU data. So we need to do some fusion with the IMU data, and we need some ICP algorithms there. Okay, so once the full perception around the machine is done, so the full point cloud is made around the machine, then you can also transfer this to the global or the absolute coordinate system. And therefore, we also need the GPS and IMU data. And why do we need that? It's because we have. This is not an unknown area. It's a known area with several uncertainties. So we know where these slab piles are with a certain level of certainty, and therefore we can stitch this on a database of the whole slab yard. Okay, so once we have these point clouds around the whole machine, so we have the point cloud, then we need to do some things with it. So we need to detect objects. So we have some bounding box detections that we use there. That's easy because we have these slab piles are quite rectangular, so that's easy. But we also have other things around the machine. So we have other machines that are also driving around there. We have other obstacles, like for example poles or casting buckets that are laying around there. So we need to see those obstacles, and you also need to classify them as what is what. So what is to be handled material, what is an obstacle, what is a moving vehicle, and if it's moving, at what rate is it moving? So if it's moving and we are moving, we can do some collision detection, and that's the next point that we need to do. So we need to see if we are moving and with a certain rate or certain accelerations, we need to see if we can hit some objects, and therefore we have done this collision detection. We are looking forward ahead of time. I think 10 seconds in some cases. This can be this differs a little bit. So we look ahead in time. We also project what other objects are doing, and if we have a possibility to hit them or not. And therefore, then if we have the results there, we can show this to the operator and also give him a warning if he makes a possible collision or not. Another nice thing or nice feature that is helping the operator a lot is the slab pile inspection. So when a machine, so you can see it here in the animation, when a machine is driving over a slab pile, it needs to be scanned, because once it's over a slab pile, the slab pile cannot be scanned anymore, and that's why, because these slab piles are quite hot. They can be hundreds of degrees Celsius, and if you put sensors inside this machine, they will not last very long. So we cannot put sensors inside the machine, but we can put sensors at or we can use these LiDAR perception, these LiDARs that we use for the perception. We can use them also to scan in those slab piles. Of course, here we are scanning while moving the machine. So here it's also, again, very important to have a good correction with these IMU data, also with the speed of the machine, with the movements of the machine. Because when we are not doing this correctly, you have these results as you see above. So you have like a fuzzy slab pile. You cannot do anything with that data. It's rubbish, let's say. But when you do this good, when you do this with the right algorithms, with the right sensor inputs, and also with the right calibrations on the machine itself, you can like have these nice examples like you see below, that you scan in these slab piles with the correct view. You can see there that these slab piles, they have longer slabs, shorter slabs, wide slabs, narrow slabs. So it's quite important if we want to have an automated machine or an automated picking unit, that you are able to see these slab piles very good, and that you have a good idea on what you are picking. Sensor fusion and data interpretation to make this LiDAR sensors, who are quite high end already, make them even more smart, and use them for really perception and obstacle detection.